it is Wednesday, December 17th, and we are here for another session of Meteorite or Meteor Wrong, which we do on the third Wednesday of every month. Unfortunately, Topher is not available tonight, so I'm going to do my best to handle his hosting duties with the help of Pat, Allison, and the rest of the crew. So tonight we're going to just do 3 rock IDs. The first one, we're going to be doing a rock hound hunter supporter ID, and then the second 2, we're going to go do a white glove session. I have 2 rocks here at my house, and they could not be any more different. So let's get started. All right, so our first rock ID of the night comes to us from JB. And JB has been a supporter for, I think, 5 or 6 months. And she usually does a rock ID every month now. And she's been doing a really good job. Okay, so JB is a returning supporter, as I mentioned. She found this rock in, I think that's Washakie County, Wyoming, a flat, barren area. There were other rocks in the area that kind of looked like it. She could only find them using her metal detector. This rock weighs about 50 grams. And so she did do a magnet test and a streak test on camera. The specific gravity test was not recorded, but as you can see, she said it left a black streak behind. It was not attracting the magnet, but she said it's metallic and detectable with the metal detector, and a specific gravity of 1.74, which I think is lower than most meteorites, if I remember correctly.
Yes.
Yeah. Think what, Pat, what's the average one? About like 3.1?
Ordinary chondrites are, yeah, in the 3.1, 3.2-ish sort of range.
Yeah, which is like ordinary is what, about 85% of the rocks that meteorites that we find.
Yes.
So JB says she observed contraction cracks, fusion crust, shiny metal flecks, and metal blebs. So and she believes that it is a carbonaceous chondrite. So we're going to look at a few photos and then we're going to watch her video. So this is what she believes to be metal blebs. And like I said, anything with the description on the side here, this is what our submitter is describing that they see in the photo. She's just showing us the scale of it next to a coin. And if anybody, when we discuss the rock, wants me to go back to any of these specific pictures, we can do that. A little pixelated on the photo, but I think it still gives us a good idea of what we're looking at. All right, so we have about a 2-minute video. And at this time, if you want to put up your hands and comment, that would be great. Make sure you have your avatar turned on or you're on video. I get to break the rule tonight, though. Ben, did you want to share something?
Yeah, is this black and white video or was just done in a real dark place?
I don't think it's black and white. I mean, I'm seeing like tan in the rock. I don't know if anybody else sees that.
Hmm.
Maybe in a little corner, but yeah, it's like but I'm having a difficult time thinking that it's a carbonaceous if he detected it with a metal detector. It's be unusual. Plus, all metal detectors these days have an iron ID. So if there was any iron or nickel in it, anything ferrous, it would have been identified by the metal detector. Uh,
Yeah, we saw the
so,
black streak on there.
so,
I know the streak tests
so
aren't
if
definitive,
it's
but
metallic, it would have to be a different metal, a non-ferrous metal.
yeah. Yeah, you can see that the magnet didn't stick to it either.
Hey Sue, I got a comment. It's Mike.
Yes, hey Mike.
I don't know if you want to go to the video where they're on the flatter side, where it's more smooth and pause it there. But if you
Okay,
look, right, you would
let's
see
see.
what
I'm
is
not really
kind of
sure where that, like right here.
let's see. Yep, yeah, we want to pause right there. So if you look at about the 10 o'clock, right, there's that divot that you would kind of almost say, hey, maybe that's a regmaglyph, right?
Here.
Yep, but if you look at the top corner of it, it's a very hard angle. See how it's throwing that shadow? Right where the break is? Yep, right there. To me, that's not something you're going to see in a meteorite because it's rolled over too far and it's actually sticking up in positive, right?
Okay.
So any feature like that in a meteorite on an ablated surface would have gotten rounded down or broken down. So the shoulders of
Like
a
this, like edge
regmaglyph,
right here, you mean?
yep, that's a very sharp edge. So if it was a true regmaglyph, it would be smooth, right? And it would kind of roll over onto the face smoothly and not cast that hard shadow.
Mm.
Likewise, where you see kind of the the texture on the kind of the middle of it there, it's not smoothed over. You can see kind of the cracks in there. Um, and so crust flows and smooths out, and that seems like it's not overly smooth. So I'm not seeing crust there. So I think it's terrestrial.
Okay. Yeah. Thank you, Mike. I'm glad we have you here.
Yeah,
Pat, what do you like to add?
yeah. So, going to expand on the topic that Mike talked about there. Yeah, this really doesn't look like crust. It looks much more like skin on smelting slag, and in that view, we can also see a bunch of small vesicles. But if this were a carbonaceous chondrite, for the most part, we would see chondrules. And the only thing that I'm seeing is some sand and rocks that are attached to the bottom of it. So
Yeah, I
I
noticed that
I
too.
think this one is probably smelting slag, and the fact that it's detectable with a metal detector
Little rocks.
uh, may mean that it's got some non-ferrous metal in it, nickel or something else that they were smelting. So I think
So, do
this
you
one
guys
is.
think that, with that being said, do you guys think this is slag possibly, or
I think it's quite possible. Yeah.
okay?
Most certainly not a meteorite.
Allison, I thought I saw your hand up, and it's down now, or someone else had
Yeah,
their.
I was just gonna say that if we see metal blebs in a meteorite, then we would expect it then to be reacted to a magnet. So that would rule out your when you think you see a metal bleb and it doesn't stick to a magnet. There's something wrong there. So
Yeah. So you guys see this part, like how it's really black right there?
mhm.
Mhm.
Like I think a lot of people think that's fusion crust. I mean, does anybody know exactly what that is? Why
Yeah.
it's so
So
It's an oxide.
okay.
So, the other thing is that I think that is skin from smelting slag, and you'll notice that's a very deep area, and as Mike pointed out, there's stuff around it that's very spiky and sharp. So that's not fusion crust.
Okay.
Sorry, Ben,
And
go ahead.
back to the use of the metal detector. So this is something the uninitiated don't know, but a VLF detector will scream on a stone that has no metal in it. Why? Because it will have a lot of either sulfides or oxides of iron. And that's mineral iron, that's not metallic. And uh, the only way I would find it believable that there is metallic metal in it is if he was using a pulse induction metal detector, because that can't be fooled.
Okay. So there's different metal detectors that people can use when they're hunting.
Yeah.
Okay. So does anybody else have another comment? I kind of want to call on Boris and get another geologist opinion on this. Am I
Yeah,
putting you
I
on the
mean,
spot, Boris?
I wouldn't, no, not at all. I mean, I think it's been covered really well by
Okay.
the comments thus far. I completely agree. I think this is some type of species of slag product. The porosity, just the texture is wrong, as Mike pointed out. The crust doesn't look like fusion crust. It looks like a terrestrial product. So I'm in agreement.
Okay, so it sounds like the crew consensus is that this is terrestrial and most likely most likely a piece of slag. Okay, thank you guys, appreciate it. So JB thought this was a carbonaceous chondrite. So I wanted to just share a few examples of ones that are authenticated by science. So here we have J. Billet Winslow-Wan. And sorry, guys, I did not pull up the carbonaceous types, but I think that Pat said earlier this was did you say a CM
Yeah,
type?
I think this one is a CM2.
Okay. So as you can see, this is definitely carbonaceous. Really small specimen, but I just thought it really captured Tarda pretty well.
It's a beautiful fusion crust.
Yeah. So this is still a really small example, but I mean, these are contraction cracks, correct?
Yes.
So I think a lot of people mistake other features for contraction cracks, but this is what a contraction, you can even have really small specimens and they can still have contraction cracks on the fusion crust.
A good thing to point out with contraction cracks, and I agree, I think a lot of people get this wrong. There's all different mechanisms that can create cracks in rocks. Contraction cracks are when the outside turns slightly liquid and then cools very quickly. And to me, it always looks like when mud dries and you get all the little cracks and the flakes that look like, like when you see a mud puddle dry up. So it's easier if you compare it to like something like that a lot of people have seen. So when they see it in a stone like this, they can say, oh yeah, that's a contraction crack, or that's a crack from freezing, or that's a crack from whatever mechanism caused the crack.
That's a great example, Chris. And so, yeah, right here, I'm sure Topher is going to post a picture of that later. Another carbonaceous, one we're all very familiar with. Does anybody have a guess as to which carbonaceous chondrite this is?
Aguasarcus.
Aguasarcus.
I was going to say Murchison.
Oh, it's I will say it's small. We've taken bigger pictures of Aguasarcus and Murchison. This one, I don't think we've taken pictures of anything larger than something smaller than the scale cube. What was that?
Winchcombe.
Winchcombe, that is correct. Yes, I know Bruce was saying it's
Wow.
not picking up what he was saying, but yes, this is Winchcombe.
That's cool.
Yeah, pretty cool. All right, guys, we're going to move to the white glove rockhound ID portion of our video here. We're going to be doing rock number 2 and 3 together. Lori and Travis both submitted rocks that we're going to look at. I don't want to really come back and look at these again, so these screens again. So we're going to just go ahead and go over the details really quickly. Travis is a returning supporter. He found his rock in northern Ohio near Lake Erie. He shipped it to us. It's a big rock. So Travis reported that he saw fusion crust and chondrules. And then the rock number 3 came to us from a new supporter, a Lori. The location is unknown. I'm not sure if the collection was given to her or someone in her family, but she says it's a collection that was given about 35 years ago, and this rock stood out as an interesting rock. It weighs just a little over 11 grams. And she reported 7 different features: contraction cracks, regmaglyphs, flow lines, shiny metal flecks, rollover lips, fusion crust, chondrules. So this rock kind of has it all. She believes that her specimen is an ordinary chondrite. Travis didn't really give a guess as to what he thought his rock was, so I'm not going to pull up examples or anything because ordinary chondrite kind of covers a lot of different types, H's, L's, LL's, Rumarudis, all of that. So we weren't really sure who was going to be doing this. So yes, it was remaining to be seen. So yes, live testing, show and tell and testing with me. This is actually rock number 3. Allison's going to remind us of where it was found, what, or more so the meteoritic features that Lori believed that she was viewing and what the weight was and things of that nature. So, all right, let's take a look at this rock.
So Lori believes that this is an ordinary chondrite. We're seeing chondrules, hopefully. We think we're seeing fusion crust, shiny metal flakes, possibly some flow lines, and some regmaglyphs, some contraction cracks, possibly a rollover lip. Kind of like you'd said earlier, just a little bit of everything that you would hope to see in an OC, in an ordinary chondrite. I can definitely see why the viewer would think that this is a chondrite, because there definitely are some inclusions in that rock. And that one corner right there looks like it could be a little rusty, so maybe some metal, kind of some things that could be meteoritic.
Where's the metal?
The metal blebs. I didn't really see metal blebs.
I didn't either.
And then as far as like the light, seeing metal flecks in the lighting, I may be seeing them little specks, but I don't think it's being picked up in the video really. So this is the 3rd month of white glove rockhound, and I found some white gloves, as you can see.
Love that.
Of course, the white gloves are fabric, a little bit harder to work with.
Yeah, so on this one, I don't think we're actually seeing chondrules. You notice many
Can
of
we,
them are very angular.
Sue, do you have your magnet handy?
I can get it.
I don't see anywhere noted if this is magnetically attracted or not.
So this is what we call a rare earth magnet. Is that correct?
Mhm.
Yes.
Yeah,
Yeah. And Topher
neodymium.
just bought a bunch of them for all of our Patreon and YouTube supporters. So if you don't have one, you're gonna get one soon. Okay, so it is. Yeah, it's not there. There isn't any pull at all.
Especially right there on that rusty looking spot. Mm-hmm.
No, I don't feel any attraction to the magnet at all.
So I don't see any crust on this. It seems like there are broken faces, but they look exactly like, every other side of it. And also some of those minerals in there kind of looks like quartz, which is not a good sign for a meteorite. So I'm leaning towards MeteorWRONG.
Hey, Sue and Allison, this is Mike. So my thoughts, so you got dark, you got things that you said, hey, kind of look like inclusions. But to me, they're not round, right? They're all pretty oblong. Some of them have kind of hard corners. So to me, they don't look like chondrules. Uh, as far as what they are, you got some pitting in there that looks like you have gas bubbles and void spaces. I got a feeling it might be a basalt where you had secondary um, calcium-based minerals forming inside the vugs. So it could be interesting to try to hit it with vinegar or something, another light acid, in order to see if you get reaction on those white-filled spots and see if they are carbonate. Yeah, like I said, you could see like right there at that angle, you could see the vugs in there, and you could see the rest of them kind of seem filled, and it looks like a very bright carbonate to me. So I would recommend maybe hitting it with acid and seeing if you get a reaction.
How about you, Dave? What have you got to add?
Okay, the only other thing I could think of when I look at some of those white inclusions, if it would be a meteorite, it would be carbonaceous. It would be calcium aluminum inclusions, though they look a little angular to me. And correct me if I'm wrong, was this found by a lake or a ocean area?
We don't know.
This is the one that was in a 35-year-old collection.
Oh, okay.
Oh, okay. This is
So,
the one
yeah.
Lori found.
Right. And so if it were carbonaceous, it would have weathered considerably unless it was in the Northwest African desert. So
Yeah, I was
I
gonna
mean,
say it's like, look at I'm pushing on it. It's not friable at all. I
right.
mean,
And so when you add everybody else's comment and the only last thing, if that just might have been a carbonaceous chondrite, that's been eliminated too.
I think you'd be seeing blacks like little, crumbs on my gloves, but
Oh
nothing.
yeah, you'd be getting all kinds of little
Oh
microbes.
yeah, especially if it was like, been in a collection for decades already.
Right.
Okay. Okay. So I think the consensus is that this is a terrestrial rock and not slag like it is with about at least 75% of our meteor wrongs. But Mike, you said basalt probably. Okay,
Yeah,
cool.
that's what I was thinking. I'm thinking it's a basalt with some filled in vesicles.
Okay. Thank you so much, you guys. Okay. All right. Rock number 2 brought to us from returning supporter Travis. And Allison, can you remind us of the facts that we know about this?
Yeah, this is tipping the scales here, Sue, at 3,228 grams. It was found in North Ohio on the shore of Lake Erie, in a clay-like environment, in a slide on the shoreline. We believe the submitter believes that they're seeing fusion crust and chondrules. So again, like you'd said, that could be a multitude of different types of chondrites, but leading me to believe that the viewer thinks that this is in fact a chondrite of some sort.
We also have a cut area.
Ah, window, fantastic.
Oh, let me see if I can zoom it all. Let's see.
And if you would, when you're done with that, show us if we have magnetic attraction or not as well.
Okay. Oh my gosh, I'm getting a workout, you guys. Oh, that is heavy.
That's pretty good. That was a pretty good view.
I don't really feel like it's, obviously I'm going to test a few different faces, but I'm not feeling an attraction really. I mean, if there, it would be like a really low LL. I mean, it just doesn't, let me see. Oh, so you can see it was very slight, but it fell off the second I turned it. Let's test the inside of it. I think we can say this has slight to no attraction to the magnet.
Yeah, just looking at that, some hearing that it was found by water. It looks like, with the exterior and the interior window looking the same. I'm not a, terrestrial geologist by any means, but it looks like basalt with phenocryst, like tiny crystals in it. And
Yeah, you're right. It doesn't
like
look different on the inside or outside.
it looks like it looks like more like a type of terrestrial basalt to me.
It's very shiny.
Yeah.
That's because it's water worn.
Yeah.
Yes. And the problem with water worn is to have survived eons at Lake Erie, which is a glacial area, it would have to be very hard, much harder than a meteorite.
I'm kind of leaning towards serpentine with a greenish color. I would ask Sue to feel it to see if it has a waxy texture to it or feel to it. I mean, it should be kind of like a waxy feeling.
Well, I'm not sure that I can accurately exactly say how it feels. So maybe Topher will add a little comment in here when he feels it.
And in that window, there was some thin, like white lats or long streaks of white. That's also something that's commonly found and associated in serpentine. So I'm leaning towards the serpentine, but it's definitely water worn for sure.
Dave?
Yeah, the that part that was cut really solidifies the idea that it's a very, very hard rock. When you look at the cut, it's quite smooth even on the cut. Without it being worn, and even the cut marks just don't look like this was a meteorite that's been cut. If something that cut a meteorite, it would have been in pieces. So this is a rock that's been sitting in a water area, tumbled for many years.
And it's dark in the inside.
Exactly.
Yeah. Like
Every
Chris had mentioned earlier, there's really not a difference between the inside and outside.
Yeah, that and everybody else's comment, that's exactly what that is.
So I want to take this opportunity to remind our white glove rock hounders, when you send something really heavy, a really heavy rock in the mail, you've got to put it in a box. You got a double box. That this was sent to us, it is really heavy. It was sent to us in a bubble mailer, and as you can imagine, it ripped right through. So it had to be repackaged by the post office. And I don't see any damage really, but if this had been like a delicate meteorite, it definitely would have gotten damaged for sure. So a box, put it in a box within a box when you send it in the mail.
Pat, do you have anything to add?
Yeah, so a couple of learning points here. So fusion crust is virtually always black and you can't see through it. And the fact that we can see the internal texture of this rock from all sides shows us that it does not have fusion crust. And yes, this looks very much like a water-worn rock, but in the areas where there's divots or, depressed areas, notice how angular it is. The bottom of those divots is not nice and rounded and smooth like it would be if it were a regmaglyph. But because this is a water-worn rock, it's bounced down a stream at some point and impacted other rocks, and that's what causes those indentations in the rock. So I agree, this one is not a meteorite. Also not seeing anything that looks like a chondrule.
And yeah, I agree with the crew. I don't see either one of those either. I also think that this looks like a very hard rock, a fine-grained silicate rock of some kind, and a very hard rock. So I'm also leaning towards terrestrial. Heavily leaning towards terrestrial, like 3,228 grams heavy.
All right, so we're going to go ahead and see if we can do a streak test.
You went across it. It left porcelain on the rock.
Oh,
yeah.
It did.
See?
Yep.
So
it left no streak.
Yep. What does that mean?
No streak, and it means the rock is really hard.
Okay. All right, guys, let's try Lori's rock out. See if it leaves a streak. We're having the porcelain leave streaks on the rocks tonight, aren't we?
Yeah. So no streak visible, and another indication it's a very hard rock.
Yep. Okay. Okay, guys, I think the crew consensus for both of our white glove rockhound submissions was that they were both terrestrial. We didn't think they were slag, but terrestrial rocks. All right, guys, thank you for watching. Make sure to comment, like, share, subscribe, and all that fun stuff. And we will see you again on the next video. And don't forget, we'll be doing Meteorite or Meteorwrong on the third Wednesday of January. So make sure to come join us live. All right, talk to you soon. Bye, guys.